my name is Joyner, and I would like to present to you the article, Does Silent Reading Involve Articulation? By Haber and Haber, 1982. Previous research has tried to make the connection between oral processing and silent reading. There's two main theories that are driving this connection. The first theory states that because reading is initially acquired as an oral process, then we never quite lose that speech basis, even when it becomes unnecessary. The second theory states that speech helps the working memory. Connor and Norman both believe that speech recoding in reading aids the working memory with words before we begin comprehension. These two theories led to further research that tried to connect the idea that speech and reading act in parallel. There are three main types of evidence that support the speech-reading parallelism. These areas are non-reading information processing tasks, interference tasks, and some direct performance during silent reading. The non-reading information and processing task supports speech-reading parallelism indirectly by showing that irrelevant phonetical features affect visual performance. Further studies have shown that misspellings are easier to identify if they cannot be pronounced. Corcoran found in his research that misspellings of words were likely to be detected when the misspellings were incompatible with the correct spelling of the word. If the word could be pronounced, the misspelling was much harder to be detected. Next, information processing tasks offer evidence to support the speech-reading parallelism by showing that interference tasks affect the speech recoding ability during reading. Levy conducted several studies using counting as an interfering task while the participant was either reading or listening to a text. He found that the counting had suppression effects that were specific to reading and not listening. He also found that the suppression did not diminish with practice. Further, the suppression was evident even when subjects were given control over their reading rates. This research that we looked at have demonstrated an indirect relationship between speech and reading parallelism. However, there is some research that have shown that there may possibly be a direct effect. Evidence to support this looked at the speech muscles while reading. Several researchers found that the speech muscles were active during silent reading. Further, Hardjack and Petronas found that college students had more speech muscle activity with a difficult text than they did with an easy text. Later, when they tried to suppress a subvocalization, they found that college students had poor understanding of the difficult text without the subvocalization. As you can see, previous research has addressed a relationship between reading and speech. However, it has not addressed whether articulatory processing has a direct tie with the reading process. Haber and Haber tried to address this in their research. They asked, does silent reading involve articulation? And they're looking to see if there is a direct relationship. They hypothesized that there would be no difference in reading times whether the text was silent or oral. If articulatory programming was required, then a difficult articulatory sentence and an easy articulatory sentence orally would be no different than a difficult articulatory sentence and an easy articulatory sentence read silently. If there is no articulatory component in silent reading, then any differences seen in the oral reading would not be evident in silent reading. Haber and Haber used two specific stimuli to get at their research question. The first stimuli they used was to get at the difficult articulatory sentence. They used average children's tongue twisters that were approximately 8 syllables long that varied in syntactical complexity and stress pattern. For every tongue twister they had a paired matched control sentence. This sentence matched the tongue twister in every way that they could. It had approximately 8 syllables long, like the matched tongue twister, and it had the same syntactical complexity and stress pattern. The only difference was that they eliminated any of the articulation variants that you found in tongue twisters. An example of this would be, she sells seashells by the seashore, as a difficult articulatory sentence. On the other side, the match control sentence for this tongue twister would be, he finds string beans at the barn door. These two sentences are matched in every way they can, except the second sentence is not as hard to say. For every sentence they had, Haber and Haber measured reading times. Haber and Haber conducted a study as such. They began by giving each participant 10 cards, and the participants were sorted to either start orally or silently, and then they switched positions. So they began with 10 cards that they would read all silently or all orally. Each card had either a tongue twister on it or a match control sentence, and within each 10 cards, the tongue twister and the control sentence were within those cards, so that they were read in the same set together. Participants read each sentence 5 times. Between each reading, participants tapped on the microphone to indicate when they were finished. This gave researchers approximate time when the participants started reading and when they finished. Researchers measured the time between the taps on the microphone, and this indicated how long the research took. The reading speeds for both the silent and oral text were measured. So, let's give it a try. We're going to try the silent reading portion. So read the sentence silently to yourself. Okay, now try reading this sentence silent to yourself. Now, think about it. Which sentence was harder to read, and which sentence took longer to read? Like the participants, you probably should have had trouble with the tongue twister sentence. It should have been more hard for you to read and for it to take longer. They were found that tongue twisters are read more slowly than the control sentence for all the participants. Further, they found that out loud reading was actually slower than silent reading. While looking at this, they also found that throughout the 5 times reading it, participants got better as they practiced. However, this did not apply to tongue twisters. There was a significant interaction in that repetition did not affect their ability for tongue twister sentences. As you can see here, tongue twisters out loud and silently did take longer than the control sentences. The difficulty that tongue twisters provided for the participants helped support Haber and Haber's original hypothesis. Silent reading does involve articulatory processing. Because tongue twisters were difficult in both the silent and out loud reading, then there was no difference between them, and their hypothesis and research question was supported. With these results in mind, Haber and Haber thought future research would benefit from addressing a few other issues they came up with. One of them is they want to look at why substitution errors were made more frequently for both initial and final consonant cluster alteration, like in the tongue twister I provided with you before. Which wishes wished wicked wishes? The initial and the final consonant clusters are altered during that tongue twister, and it makes it more difficult to say. They also want to look at why unstressed syllables give our tongue a break. What makes these unstressed syllables alternating between more complex syllables let our tongue be relieved? Also, they wanted to look at why sounds of juxtaposed vowels are harder to say. For an example, toy boat. Try saying that 5 times fast. I tried a couple times, but it's not pretty. Toy boat, toy boat, toy boat, toy boat, toy boat. Those juxtaposed vowels are very difficult for us to pronounce. In the end, Haber and Haber furthered the research in subvocal articulation.